Oh, good morning. Last time I spoke about the limitations of our data science. Now, today, in the short, uh, I am going to show you about the anatomy of our machine learning and what are the machine learning algorithms are very powerful in terms of the data science or data analysis. So, what we say that the most common use of machine learning principle are in prediction domain. Whenever we are trying to do some kind of analysis, we would like to do a prediction of a stock exchange market, what is the value of a share will be tomorrow, what value it will acquire day after tomorrow, and things like that. That means most of our work, it relies on predicting some outcome, predicting some value, diagnosing a person with a disease. So, it's more of a like a prediction we are going to do with the machine learning principles and algorithm. Predictive algorithm tells us when something will happen, but not necessarily why it will happen. So, I might have got a corona, but what was the reason exactly, nobody knew precisely. So, we use a word prediction or predictive algorithm tells us when something will definitely happen, but we are unable to identify what is the necessity that it has happened. So, some examples of predictor or predictions task are, will this user churn out in the next month? So, I am a user, will I be able to retain the user for the next month, or if I am going for a shopping mall, will the user will come back in the next month with a more and more amount of expenditure. Next, when we, does this person have a high risk of developing a Alzheimer disease? Now, as I have been saying, health prediction or health is the most important thing for all of us. So, as we go along in the age, when the age rises about 60, 65 or nowadays 45 and 50, the chances of Alzheimer diseases are sometime remote, sometime may happen. Alzheimer disease is one of the diseases where the person loses the memory. He is not, or he or she is not able to identify even the person who is looking at him or her, and the whole body is active but the mind is forgetful. So, it is a big problem and a high risk is involved if a person have a Alzheimer disease, and the most brilliant example of Alzheimer disease was Ronald Reagan, earlier US president, when he got the Alzheimer disease. He forgot his wife also, and he used to roam around the US street, and people just recognize him, oh, this was our ex-president, and they took him away, they took him back to the home. So, it's a high risk problem. Will there be a traffic jam in the next hour? So, if you look at all these three examples, all these three talk about the predictions. Okay. So, often we want to have a explanation instead of prediction. So, sometimes I want a explanation why and why it has happened. That is what we say, that we may not necessarily know why it is happening, but we would like to know what is the explanation instead of the predictions too. So, solving an inference task means to find out a support evidence to some of the claim in the data by asking a question why it has happened. Why person got a brain stroke? What was the reason that person has got a Alzheimer disease? What was the reason for a person to get a paralysis kind of thing? So, for example, let us say a explanation why this person win the election. Only one particular person win the election. What is the reason? Why he is really every time he is able to win from his own constituency? Okay, so this is one of the question where explanation is also required apart from the prediction. Why does this medicine work and it will not work for other? So, some medicine will work for a particular person, some medicine may not work for the same medicine may not work for the other person. So, that means you are trying to have a explanation point, and explanation will give you a prediction, oh, why this medicine could not be successful, why this medicine make a good effect. So, these are the anatomy of our machine learning algorithm, and what we say that I want to have a prediction based upon the statistic. The reason is statistics is very powerful because it will predict with a certainty, with a probability. So, statistical inference help us to find out an explanation or to prove the efficiency of our actions. So, I am prescribing or a doctor prescribing you a particular medicine, or a person is having a chances of winning the election. All those things are having a explanatory as a one of the paradigm. So when we do a inference, we seek answer for the present and what has happened in the past. So maybe the person who got elected must be doing very good job in the previous years, and that's the reason he or she is being elected from the constituency. So you are looking from the angle of a present and the previous, that is past. So when we try to look into the future, predictions come into the picture. So what is prediction? It is a future. I want to forecast, is the same candidate is going to win or not? Is the same medicine going to work or not? So sometimes we are not interested in predicting the future or a finding of a evidence, but we want machine to recognize a complex pattern of the data. So many times it is not very clear, okay, and what we want from the machine learning algorithm is, I want to recognize a complex pattern in the data set itself. So where human is incapable of identifying a particular pattern, such as object in an image. So I give you a lot of images and I want to identify an object in the image, or to analyze the sentiment of a person in a given text message. So this kind of problems are what we call as this group of tasks is called as recognition problem. Okay, so ML cover many topics, many types of flavors of model, but why do we need such a variety of different algorithm? We use the word, there is no free lunch theorem, and free lunch theorem says that a model may be working for one may not work for another. So it is said that there is no best model that will consistently give you the best result on each of the tasks and every data set. We say that ML algorithm cover many types of flavors of model, but we do not need such a variety of different algorithms. So we use a word called as no free lunch theorem. It says that no best model that will be consistently giving you the best result on each and every type of the data set. So some model may fit on a particular age of the group, some another model will fit on a particular another age of the group or another set of patient. So each algorithm has its own benefit and pitfall. It may work flawlessly on one task, however, it will fail miserably very well at another task. So this is the underlying principle of our model. It will succeed on one, but it will miserably fail on another. So I should be more interested why it failed. So I need an explanation. So one of the most important goal of our data science is to find the best model to solve the problem at hand. So I have a problem and I need to solve in the hand. So machine type of algorithms to solve the problem. So I'll just take one example. So for example, if I have a retail outlet store, so no free lunch theorem states that there is no best model that will solve the task at hand. The consequence of is that we have many algorithms to specializing the solving a particular task. For example, I'll take an example one. For example, let us look at a fashion retail warehouse demanding forecasting. So I have shown you here a picture or a caption of a retail warehouse, okay, where ready-made garments are being sold out. So a retailer sells a fixed set of cloths at their store, but before an item makes it to the shelf, it must be bought from the manufacturer and transferred to a warehouse. So that is called a supply chain. The manufacturer will manufacture, it will go to the distributor, and from distributor it will come to the retail outlet. So let us assume that the logistics cycle takes 2 weeks. How do we know that the best quality of each item to order? So how do I predict that a particular set of cloths are being sold out many times? So there is a good chance that we have a item sales data for each of the store. So we can use this to create a predictive model to estimate that average customer demand for each and every item of our catalog warehouse in the next 2 weeks. So what is going to be the next order in the 2 weeks, I have to predict. So this is exactly a prediction task. Now imagine a retail outlet given by Reliance or given by Tata companies or given by many garment industry manufacturer. They use this kind of modeling for a machine, and machine will identify how many particular items have been sold. They will supply, they will give this information to the warehouse, and the warehouse information will go to the retail manufacturer. So it is a complete supply chain problem or complete supply chain. So that is why we forecast an average number to be brought into the 2 weeks time. Okay, so So simplest model would be taken average demand on each of the items the last 2 weeks and estimate a future demand. So that means I am estimating a future demand. Okay. So simplest statistical model like this are frequently used for a real store. So we do not have to have simplification. So what do we want to do? For instance, let us look at the, okay, so we have a fixed set of cloth and we can use it for the, okay. So I'll take the next time another example of the telecom industry, where I'll show you security is a very important concern. So right now I'm stopping here, and thanks you for patience listening.